Hi there, in this video we're going to be solving the following problems. So we need to use the differentiation rules, not the definition of the derivative, to calculate the derivatives of the following functions. So first up we have we have square root 7x to the 4 plus 3x squared. So the particular rule I'm going to be using here, I think, is going to be the chain rule. Now notice that we have a square root there, so I'm going to immediately get rid of that square root, or just write it in a more usable manner by having it like this, to all of that to the 1/2. That's equivalent to having it square rooted. So it's a lot more visible as to what we need to do. So now what we're going to be doing is finding the derivative of what's on the outside first, and keeping what's inside the same. That's according to the chain rule, basically the chain rule is like this. So we find the derivative of the outside, we leave g the same, and we multiply this by the derivative of g. So that's basically the chain rule. And in this case, the outside, all of this here is going to be f, and everything inside here is going to be g. So that's what's going on right now. So we're finding the derivative of f, which can be the outside here. So that's going to be 1/2 multiply everything inside there. And then we're also going to have it, so it's going to be 7x to the 4 add 3x squared, then negative 1/2. So if you want to rewrite this, it'll look like at the end 1/2 multiply the square root of 7x 4 add 3x squared, all of that square rooted. So this is the first part, but we also have to multiply it by the derivative of everything inside. So we multiply this by what's the derivative of 7x to the 4? Well, that's going to be, we put the 4 down to the 7. It's going to be 7 times 4. That's going to be 28. So we have 28x, and we do 4 subtract 1. So it'll be 28x to the 3. And now we take the derivative of the next portion, which is this one. So it's going to be add, then we have put the 2 down, that's going to be a 6, so 6x, then just 6x. And this is going to be almost to the end. Let's just simplify it a bit further. So if we multiply this across, it's going to look like this. So what we can do right now is just cancel out the 2, factor out 2 from the entire thing here, and we get, right here it would be a 14. So it would be 14x cubed add 3x over just the square root of 7x4 add 3x squared. And this here is actually the derivative of a. Okay, so we got question A down. Let's go and do B, shall we? So B is going to be right here. So B has it has quite a bit, it looks like. Again, I think I'm going to be using the chain rule for this one. So let's do the outside. We have a 5 on the outside, notice. So it's going to be 5 out here. Multiply everything inside, which we're going to be leaving the same. So it'll be just e 3x squared plus 2 sine 4x. And then we do 5 subtract 1. And now we put a 4 out here instead. And now we have to multiply it by the derivative of everything inside. So what is that going to be? Well, the derivative of e to the 3x squared. For that, we need to use the chain rule. And it's actually going to be e 3x squared. And then we find the derivative of what's on top. So we put the 2 down to the 3, that'd be 3x, or 6x. And then we just multiply it out here. So this right here is the derivative of e to the 3x squared. So that got rid of the first part. Now we need to find the derivative of the second part. So the first thing we want to do is factor out, or just ignore the 2 here, because it's a constant, and we usually just ignore those while we're trying to find the derivative of everything else. So notice we have sine 4x. That's what we need to find the derivative of. So in order to do that, we actually have to use the chain rule again, which is quite something, because we're using it with chain rules within chain rules, it's something indeed. Now, I'm going to find the derivative of what's on the outside, leave the inside alone, and then we multiply it by the derivative of what was inside. And what was inside was 4x. So that's just going to leave me a 4. So we just have a 4 on the outside. And this is the derivative of sine 4x. So that's going to go right over there, right just here, which is off screen. So I'm gonna kind of move it down. Okay, so I just rewrote it down here, and we stopped where basically we found the derivative of this portion right here, the sine 4x, which is what we wanted. Now we have to also, I forgot one tiny little aspect here. There's actually the constant 2 that I kind of ignored. I didn't put it back. There's actually a 2 right there. So let me just draw the 2 in. Okay, so now the last step is just to kind of simplify this a bit, because notice we have a 4 right here and a 2 right here. Those can be erased and put an 8 there instead. So let me just, I'll erase that 2 and erase this 4 as well, and I'll put an 8 there because 2 times 4 is 8. So that's more simplified. It looks better. And this would actually be the derivative of b, of this function right here. So let me just, that's quite a bit. So gotta kind of make some room here. Wasn't expecting so much. Okay, so now we have one last question to solve, C. So C looks pretty interesting. Again, we're going to be using the chain rule on the outside. So let's draw. Okay, so it's going to be 1. So let me just put everything like this first off. It's going to be 2x add, then we have square root 2x inside here, and all of this is going to be to the 1/2. We put the 1/2 on the outside. We do 1, or basically this subtract 1. That will give me negative 1/2. So in the end, it's going to look like 1 over, yeah, basically 1 over square root 2x add the square root of 2x again. And now we have to multiply it by the derivative of everything from the inside, which is going to be quite a bit. So what's the derivative of 2x? Well, that's just going to be 2, I believe. So it's just going to be a 2. And then we add it to the derivative of what's the derivative of square root 2x? Well, using the chain rule again, it's going to look like 2x to the 1/2, remember? We put the 1/2 on the outside. This becomes negative 1 because you subtract it by 1, which means in the end it's going to look like 1 over. So it'll become 1 over 2 multiply the square root of 2x. And you have to multiply this by the derivative of whatever was inside. What's the derivative of 2x? Well, that's going to be just a 2. So you multiply it by 2. Notice the 2's cancel out. So the derivative then of square root 2x we get is just going to be 1 over square root 2x. Pretty weird, but that's what it is. So we just do 1 over square root 2x. And let me just erase this here. Oh yeah, one thing I forgot was, notice that when I took the derivative of this portion right here, oops, I keep changing the wrong colors. When I took the derivative of this portion right here, I totally forgot to put this 2 right here, right inside this, because there would be a 2 multiplying all of the bottom here. Then all of this would be under the 1 here and square rooted. So let's just let's multiply this across now. So it's going to look like all over, and then we have a 2 down there. 2 multiply the square root of, we have a 2x down there, and an add square root 2x again. And this is going to be the derivative of our function. This is question C. Okay, so I hope you enjoyed this video. If you have any questions, feel free to ask in the comment section below or private message me. I'll be happy to answer your questions. And I do hope you're having a fantastic day.